Welcome to the deep dive. There are a few things quite as, well, universally frustrating as getting some cryptic error message popping up.
Oh, absolutely. It can feel like the software's deliberately being obscure.
Right? Or just throwing its hands up. But what if we told you those annoying pop-ups are actually pretty fascinating? Like little windows into how software really ticks.
You're right. That's a great way to put it. They aren't just roadblocks. They're signals. Diagnostics, really. Each one tells a bit of a story about the software's logic.
How it sees data, how it talks to the system, what it expects.
Exactly. The rules it plays by.
So that's our mission today. We're diving into a specific set of error messages from an application called the EnergyPLAN model.
Right. Used a lot in energy system analysis, and it's very particular about its input data, things it calls distribution files, distribution libraries, basically where it keeps its data.
And we want to sort of transform these cryptic annoyances into useful insights, help you understand what's going on under the hood with complex software. Ready to unpack this?
Let's do it.
Okay, first up, let's talk precision. Or maybe the total lack of forgiveness computers have for exact specifications.
Yes, of that strictness.
We've got an error message here that nails this. One of the distribution files has too many or too few lines. It must have exactly 8,784 lines with exactly one value in each. See section 3.2.2.
That is such a perfect example. It's not, around 8,000 lines.
No, it gets 8,784.
Precisely. And every single one of those lines, just one value, no more, no less.
Wow. Why so specific, though? 8784.
Well, it's not arbitrary. For EnergyPLAN, that number, 8784, usually means hourly data for a whole year.
Ah, okay. 24 hours times 365 days.
You got it. So if the number of lines is off, the model just doesn't know which data point belongs to which hour of the year.
It's like a really sensitive recipe, isn't it?
That's a great analogy.
If it says exactly 2 cups of flour and you add just a tiny bit more.
The whole thing might fail. Yeah, the model can't guess or approximate any deviation there, and it can't align the time series data it needs.
So it just stops.
Stops dead.
Yeah.
It really highlights how vital data integrity is right from the start.
Okay, so sometimes it's the number of lines, but other times it's what's in those lines, right?
Exactly. Which brings us to the next common issue. Data format mismatch.
Right, the error message here is one of the values in one of the distribution files contains letters instead of numbers. In this case, 335,000H should be replaced by 335,0 or 335,0.
And this points to a really fundamental rule in computing. Numbers are numbers. Letters are letters.
The computer doesn't blur the lines.
Not at all. It's incredibly literal. If it's expecting a number for a math operation, it just cannot compute H as part of 335,0.
Even if it seems like an obvious typo to us.
Right. Or even something subtle, like using a comma for a decimal point when it expects a period, or vice versa, depending on the system's settings.
That tiny difference can halt a really complex calculation.
Absolutely. Because it's not just a typo to the machine. It's the wrong type of data. It sees H and flags it as invalid. It can't proceed with the calculation.
So this isn't just about, neatness. It's fundamental to how computers work. They need absolute, unambiguous instructions.
Precisely. There's no room for guessing or close enough, like in human chat. What you define is exactly what it expects, nothing else.
So for the model to run, every single piece of data has to be in the format it's built to understand.
Which is why data validation, checking the input, is such a critical step in good software design.
Okay, so we've talked structure, we've talked content. What about where the files actually are?
Ah, yes. File management, system organization, very common source of errors.
Yeah, I bet. This next message sounds familiar. The stated distribution file, in this case WinWest DK 2009, cannot be found in the distribution library.
Super common, happens all the time. There are a few usual reasons for this one.
Like what?
Well, a big one is getting data from someone else. Maybe they created their own custom distribution files, like that WinWest DK 2009.
And if you don't have that exact file,
In your distribution library, that specific folder, the model is programmed to look inside, then it can't find it.
so you either have to change your setup to point to a file you do have,
Or you need to get that missing file, that WinWest DK 2009, and put it in the right place, in the distribution library folder.
makes sense. Making sure the software finds what it expects, where it expects it. But you mentioned a twist, something about different versions of EnergyPLAN.
That's right. The same error, file not found, can pop up if you've upgraded the model itself. Say you replaced an older version, like version 9 or maybe earlier,
All right.
with a newer one, like version 10 or later.
And the new version looks for things differently.
Kind of. It introduced a new requirement for organizing things. You now have to create a specific main directory called EnergyPLAN data.
EnergyPLAN data. Okay.
And inside that directory, you need 3 specific subdirectories holding the essential data.
Mm-hmm.
One for data, one for distributions, and one for cost.
So if that whole EnergyPLAN data folder structure isn't set up correctly,
The newer version just won't find its components. Even if the files themselves are somewhere on your computer, it leads straight back to that cannot be found error.
wow, that really drives home how important file organization in these directory structures are. It's not enough to have the files. They have to be in the exact place the software is coded to look.
It's like giving someone directions. If you say turn left at the big tree, but the tree isn't there or it's down a different path, they're lost.
Good analogy. Okay, let's shift gears a bit. Let's talk core computation, math.
The fundamentals.
Specifically, mathematical calculation errors. This one seems maybe obvious, but it must cause endless problems. The calculation has been interrupted because of division by zero.
Ah, the classic. Division by zero. It raises that key question, why is it impossible in computing?
Right. I mean, mathematically, it's undefined.
Exactly. There's no single finite answer. You can think of it as approaching infinity. But a computer program needs a concrete, calculable result to continue. An undefined result, that's a dead end.
So if an input value that's going to be used as a divisor, in the denominator of a fraction, accidentally becomes zero.
The program just halts. It can't perform the operation. Crash.
Okay. So the standard workaround mentioned is replacing zero with a really small number, like 0.0001.
That's common practice.
But thinking about a model like EnergyPLAN that's built for precision analysis, doesn't using 2.0001 instead of true zero introduce its own inaccuracies, potential side effects?
That's a really sharp question. And yes, it is a compromise. It's pragmatic. Using 0.00001 introduces a tiny, usually negligible error.
But it lets the calculation continue.
Right. The alternative is the program simply stopping altogether. It's often seen as the lesser of two evils. I remember spending ages once tracking down an error in a spreadsheet because a cell used for division sometimes hit zero. It's a trap.
I can imagine. But what's interesting here is the human element mentioned with this error message.
Oh, yeah, the instruction to email the developers.
Right. It says send an email to lund@plan.au.dk with the error details.
That's actually fantastic. It shows a direct feedback loop. The developers want to know when and why this happens.
So they can potentially improve the tool, maybe add checks, or handle it more gracefully in future versions.
Exactly. It shows software isn't static. It evolves based on real-world use and, well, the problems users encounter.
That's really cool. Okay, our final error for today. This one feels a bit more subtle. It's about operating system features interacting with the software.
Yeah, this one can be tricky to diagnose.
The problem described is the name of the input data file is not showing in the upper left corner of program and the print.
Right, and the likely culprit here isn't the data itself or even its location in the model's folders necessarily. It might be an external setting.
External, like what?
Like the Windows Offline Files feature.
Windows offline files. What does that do?
Well, it allows Windows to cache network files locally so you can access them when you're not connected to the network. But it can sometimes create confusion about where the file actually is or how it's being accessed.
So the program might think the file isn't really local, even if it appears to be right there on your computer.
Exactly. It can sort of obscure the true file path or access method from the application's perspective. It's one of those features that can be useful, but
Can cause unexpected problems if you don't know it's active. I bet IT support deals with that one a lot.
you're probably spot on. It leads to these subtle issues that are hard to figure out unless you know about this potential system interaction.
So what's the core problem for EnergyPLAN here? Why does offline files mess it up?
The documentation explains that basically all the units, meaning the main program file, the executable, and those key libraries, data, distributions, and cost.
Yeah.
They all have to be located and running from the same hard disk, physically the same drive.
Not just logically accessible, but physically co-located.
Correct. If Windows Offline Files is managing one of these components, or if you've perhaps installed parts of the program or its data libraries on different physical drives,
Then the program can't establish the direct links it needs between its parts.
that seems to be the issue. It breaks that fundamental organization, leading to symptoms like the file name not appearing correctly.
Wow. That really highlights how things outside the software itself, operating system settings you might not even know are enabled, can have a big impact.
It's not just the code or the data, it's the whole environment they operate in.
It underscores that idea of like system harmony, doesn't it? Everything needs to work together.
Absolutely. The code, the OS, the hardware, they all need to be in sync for things to run smoothly.
Phew. Okay. That was quite an exploration of these digital distress signals.
It really was. And when you break them down, these error messages, they really do offer some deep insights, don't they, into how software is built, how it handles data.
Totally. We've touched on, let's see, the need for really precise data structures, like that exact number of lines.
And how critical file organization is, especially with different software versions.
Right. And the mathematical rules, like avoiding division by zero.
And those tricky interactions with the operating system itself, things you might not even think about.
Yeah. I think the big takeaway here is that if you can understand why an error message is popping up, it changes everything.
It moves you from just frustration to actually comprehending what the system needs, what rule was broken.
Instead of just clicking OK and hoping for the best, you can start to piece together the puzzle.
Precisely. Which leads us to a final thought for you, the listener, to chew on.
How might understanding the rules behind a software error, why it failed, help you troubleshoot other complex systems, not just tech?
Yeah, think about a project at work, maybe a personal goal, even, relationships sometimes, recognizing where the data might be off or the structure isn't right.
Or where the fundamental rules aren't being followed.
Exactly. Could that understanding lead you to better submissions in all sorts of areas of life? Something to think about.